Hi guys, today we are going to do a yeast respiration lab. I'm just going to show you the general setup here. So we have 4 bottles labeled with different sugars, 4 cups labeled with different sugars, and right now there is 10 grams of each of the sugar in each cup. So 10 grams of glucose, 10 grams of lactose, 10 grams of sucrose, and 10 grams of maltose. I'm waiting for the water to get to a good temperature right now. It needs to be between 37 and 40 degrees Celsius. And then I'm going to add 200 milliliters of water to each cup. Okay. The other thing we're going to add to each cup is a packet of yeast. And then we're going to allow the yeast to activate a little bit. And what we're going to be doing in this lab activity is determine which type of sugar is going to cause the most cell respiration. The way we're going to measure the cell respiration is by using a balloon. So we're going to put a balloon on the top of each bottle after we place the yeast sugar solution in each bottle. And then after every 5 minutes for about 20 to 30 minutes, we're going to measure the circumference of the balloon to see how much CO2 was produced and is going into the balloon to determine which sugar actually allows the most cell respiration to take place. Okay, the water is just about the right temperature. So what I'm going to do is I'm going to start adding the water, 200 milliliters of water to each cup. We're going to mix it up a little bit, and then we're going to pour it into the bottle with the yeast. Okay, I have a string here that will allow us to measure the circumference of the balloons, and then we also have a meter stick down here to help us determine the circumference. Okay.
Cold in your room. All right, I'm going to go eat my lunchy lunch. I don't know how much longer.
So at this point, all of the water has been added to the cups. So we're just going to start pouring the cups into the bottles, and then we're going to add the yeast. Of yeast per bottle. All right, I'm going to place the balloons on top. I'm going to shake it up a little bit. Oh, yeah. And the last one. Oh, what's going on with my glucose balloon here? All right, well, here we are. Okay, so we'll see how this goes, and then every 5 minutes I'm going to be measuring the circumference of the balloons to see, if cell respiration is taking place and which sugar is going to be the best. All right, guys, so make sure you have your data table open. We are going to start getting your data. So I'll start with glucose. So we're going to get the circumference for glucose, okay, for the first 5 minutes. Okay, so for glucose, it is 13 centimeters. So they're all going to be in centimeters. Okay. Lactose is 14 centimeters. Sucrose is 11. And maltose here, which is hurting right now. And maltose is 10.5. And those are all in centimeters. All right, so now we're going to let it go another 5 minutes and see if any of these change. All right, guys, so we're going to do the data for 10 minutes now, okay? So make sure you're copying this down into your data table. All right, starting with glucose. Again, we're in centimeters. We are at 14. So glucose at 10 minutes is 14 centimeters. Okay, lactose is hurting here. Okay. Maybe. Okay. Okay, lactose went down to 13. Sucrose is at 14. And maltose is at 11. Okay, so make sure you write those down for 10 minutes, and then we'll let it go for 2 or 3 more rounds. All right, guys, so now we're at 15 minutes, and we're going to get the data for 15 minutes, okay? So our glucose is at 16, and again, these are all in centimeters. Oh, lactose, not doing fantastic at all. Still at 13. Okay. Sucrose is at 17. And maltose is at 14. Okay, so we'll let it go again, and you will get more data in after 5 more minutes. All right, guys, so here's 20 minutes. I think we'll do one more round to make it 25 total minutes, but here we go. So our glucose is 21 centimeters. Lactose is still terrible. Let's see. I can't even, like, measure it right now. All right, let's see. All right, the lactose is 12, so lactose is going down apparently. All right. Sucrose is 22.5, and the maltose is actually starting to do something right now. And saying up is 14.5. Okay, so we'll do one more round and make it 25 total minutes, and I'll get you guys the data in 1 minute, or in actually 5 minutes. All right, guys, here's our data for 25 minutes. Let me write this down. So 25 minutes glucose is at 23 centimeters. Okay, lactose is actually standing up now, so that's a positive. Okay, lactose is at 14. Okay, sucrose is at 25.5, and maltose is at 14.5, so that one hasn't changed. All right, and I lied to you before. We're going to go one more set of 5 minutes to make it 30 minutes total, okay? All right, guys, we're going to get our last set of data. Again, this is for 30 minutes. Okay, so our glucose is at 26.5. All right, lactose is at, oh boy, poor lactose. 14.5. Sucrose, we're at 27.5. Okay, and lastly, maltose is at 15. Okay, so that's your data. Okay, again, you can see, you know, what happened. Remember, with cell respiration, CO2 is released, okay, by the yeast, and what's happening here is the CO2 is filling up the balloons, and the size of the balloon can help you determine how much CO2 is made and give you like a rate of respiration. If you look closely too, you can see in the bottles the foam, so we see glucose and sucrose creating a lot of foam, and that's another indication that CO2 is being produced. Okay, so that's the lab. What I'm going to do is I'm going to clean up now, and then you guys can start working on your analysis questions.